Welcome back to another math help video with Mrs. Reynolds and
Mrs. Bear.
We're going to talk this time about using elimination to solve systems of equation, but we're going to talk about what we have to do when we don't have a neat set of systems, when there's nothing that is a clear addition or subtraction. And we're going to use this word called scalar, which means what, Mrs. Bear?
We're going to multiply the entire equation by something that either scales the values higher or scales them lower.
Nice. Okay.
So this first equation, if I were to just add or subtract, it's not going to eliminate either x or y. So I need to change x and y, or x or y, so that one of them does cancel, does eliminate. So I was thinking I could multiply this entire bottom equation by 7, and that would have a positive 7y and a negative 7y, and those would cancel. But Miss Reynolds, you had a different opinion.
So when I look at this, I think it's easier to think of multiplying by -3, and then you would end up with a negative 6x here and a positive 3y. It seems like easier numbers, but I think either would be about
so multiplying by 7 is just not as fast, I think.
Yeah.
Right? Multiplying by 3 or -3 is faster. So I'm going to distribute that -3. Now I have negative 6x plus 3y equals negative 66.
Okay.
So, oh, I should have written that down there. That's okay.
That's okay.
So put that there in your own notes, please. Now it says to solve the system. So I need 6x plus 7y equals 26. Negative 6x plus 3y equals negative 66. Now I can add. My x's eliminate, they cancel out. So I get 10y when I add the y's together. 26 and negative 66 is negative 40. Divide, and y equals negative 4.
Nice.
I could plug into any equation to solve for x. I actually think it's easiest to plug into this second equation right here, just because the y has no coefficient in front of it. Well, it has a -1 technically, but I just think it's faster. So I'm going to go 2x minus negative 4 equals 22. Subtracting a negative is like adding, right? So that's just 2x plus 4. Subtract 4 from both sides. 2x equals 18. Divide by 2. And there you have it. X is 9. Y is negative 4.
Yay!
Next one. Again, if I were to just to add or subtract, I'm not going to eliminate x or y. So I could choose to eliminate x, or I could choose to eliminate y. If these were both the same number, I could eliminate them. Miss Reynolds, what could 2 and 5 both become?
They could both become 10, probably most easily.
Yeah.
Or the y's could both become a kind of 2.
Exactly.
Easily.
But I need one to be positive and one to be negative for them to cancel. I think it's easier to do the y's on this one. What do you think?
I think I agree with you.
So if this is already a -2, it would be great if this was a +2. So Miss Reynolds, what do I need to multiply by to make this y become a +2?
I say by -2.
Yep. Distribute. I'm going to put my new answer down here. I get 4x plus 2y equals 18. So I distributed that negative all the way through. And then I had my second equation that didn't change. And now I can add these together. My y's cancel. That gives me 9x equals 36. I like how nicely these numbers are working. Much better than the fractions in the other video. And x is 4.
Nice.
Now I need to find out what y equals. I could use either equation. Which one do you think would be easiest to plug into, Miss Reynolds?
You know what? I'm actually going to choose equation 2 because sometimes all the negatives
Mess people up?
Yeah.
Yeah, so I'm going to go back to this equation here then. 5 times x, which is 4, minus 2y equals 18. That'd be 20 minus 2y equals 18. Subtract 20. Negative 2y equals negative 8. Be careful of that negative there. You could always add the opposite.
Wait, is it 18 minus 20 negative 2?
Oh, sorry, negative 2, yeah. I can't add and subtract today. It's a good thing Miss Reynolds is watching me.
It's Wednesday.
That's the second time I've made a mistake today. Negative 2, there we go. Divide. I'm out of room. Y equals 1.
1. Nice.
So x is 4, y is 1. And there you have it. You guys can do number 6 on your own, please. Thank you.